All right, guys. You're starting with your notes here. All right, guys. So 4.5 day 2, we're going to start with the dot product. The dot product is sort of like multiplying for your vectors. It's very, very easy. Let's look at the examples here. So part A there in the middle, you're given vector v and vector w, and then it says find v dot w. You are just going to take your x components, so I'm going to do 2 times 5, add to it -3 times 3. And we get just a number, so what do we get for this one? What do we get? Mumbling. 1. We get 1. So that was v dot w. What do you think is going to happen if we do w dot v? No, like, is it going to be the same answer? Yeah, because think about 2 times 5 or 5 times 2. Is that really going to change anything? No, so that one is also going to be 1. You guys try C for me. Do w dot w. That's how the formula works for you. Yeah, you just, there's a lot of, and like you'll see in here, there's some other formulas down here, and you don't have enough math knowledge yet to prove these in multivariable. You actually will prove some of these vector rules, but right now you just have to go, all right, so when I see dot product, I multiply and add. So what'd you guys get for C? 34, good. So dot product easy? Yeah, okay. Let's look at some of these properties down here. This third one especially, that's one that you'll do a proof for in multivariable, but right now you have to just trust that that's essentially what you're going to do. If you see u dot v dot w, that's u dot v plus u dot w. Like, there's just, you have to go with the formula right now. The first one is helpful, understanding that the magnitude squared is just the dot product. We can look at that one. Like, let's say we have vector v and it's 3, 2. What's the magnitude of v then? I'm hearing a lot of mumbling. What? Yep, if u, v, and w are vectors. So what's our magnitude of v? Square root of 13, okay. So if I want to show this, let's do v dot v then. What would we get? How do I do that? Right? For that, do I get 13? Is that going to be the same as the magnitude squared? Yes? Okay. So that's just another way you can think about that. Questions so far? It's the dot product of u and u or v and v. Like, you don't really say squared, you say dot product. I know it seems very minor, but that's just terminology with your vectors. Yeah. Elizabeth? That is something you would prove in multivariable. That is what you would understand in multivariables. Like right now, you do not have the skills to understand what's happening. You just have to know that that's what you do if you see that. Yeah. Okay. It's one of those where for right now you just have to go, okay, and later you'll understand. Those of you that make it multi will understand what happens.
So if you, it's like for vector v squared is just v dot v. When it makes the vector v like raise to the 1/2 or the vector v raised.
So you do not have, you have magnitude squared, like we have that squared, and we have this. You're not going to have, you're never going to have like v to the 1/2. Like we're not going to do that. Okay. Is that what you're asking?
Yeah, or like v to the third, would that just be v times v times v?
So it's not v squared, it's the dot product of v and v. So like v dot v dot v, well then you're looking at this.
Okay, so it's v
So
dot v plus v dot v.
yes.
Okay,
Okay.
yeah.
All right. It's different than what you're used to thinking about with
Right, yeah, it's kind of
Okay. But I'm not going to do that to you. Okay.
That's like 4 v's, you're taking like 3 v's.
I know, I'm not going to do that. Yes. Not really. Mhm. Guys, this is not a big focus of your quest, okay? Don't get bogged down too much. These are just properties of vectors. All right, let's look at this guy. So if we were going to do angle addition here to start with, like if we'll call this side blank, do you guys agree that like b plus the blank equals u? Does that make sense to you? Vector addition, so like displacement, if I did b plus this, that is vector u. Yeah, okay. So we need to solve for the blank. I guess we'll write that up here. So b plus my blank equals u. So what does the blank equal? You can do it, guys. Solve for the blank. What does it equal? U minus v. Okay with that? Okay. So the angle between vectors here. Let me erase this just to give myself a little more room. Do you guys remember your law of cosines, like when we had a squared equals b squared plus c squared minus 2bc cosine of a? Yeah? You're like, oh, what are you going to do with that? So if I am solving for theta, what?
I don't remember.
You don't remember law of cosines?
No.
Really? You guys? Oh, gosh.
Cosines are,
I'm a little worried about this quarter test.
cosine, I believe that's cosine.
So you don't remember anything that happened
Cosine
before
a
break.
squared equals
Okay, so
cosine.
Rebecca, I got the formula written up here. It's okay. Yeah, you need to remember law of sines, law of cosines. We've got like, it's like a whole unit that we did. Yeah, okay. Yeah, that's going to be like a good, 40% of your quarter test. Yeah. Oh, okay.
That'll come back.
All right, guys. So this part is like a percent number of your input.
Yeah. All right, so what I'm doing here, and then cosine theta, I can squeeze it in. Guys, I'm showing you where this formula comes from that's in the box down below. All I'm doing is writing it out. Remember, if we had magnitude squared, it was just the dot product. So again, magnitude squared, dot product, magnitude squared. So those are still just magnitude because they weren't squared. Okay. We're just going to do a little algebra stuff here. If you just want to remember the formula, that's okay, but this is where this comes from. So if I multiply this out, I'd have u dot u, I'd have minus 2u dot v, and I'd have plus v dot v on this side, right?
Oh, yeah.
Okay, good. Come back.
I didn't change it.
2bc, is that what you're talking about, or this one? So think about like boiling, like dot product, that's all. Back to just multiplication. So if I were solving for cosine of theta, do you guys see anything that's going to happen? Like if I bring these u dot u's over, what happens? What about the v dot v? Okay, I would then be dividing by this, right? So what's going to happen to the two negative 2's? You guys see how those are gone? So we're getting rid of a whole bunch of stuff in one step here. So I'm left with u dot v over the magnitude of u, magnitude of v equals cosine of theta. You guys see how that is that formula down there? Okay. Wow.
That's really good.
I know, it got a lot smaller really quickly. So it does come from somewhere. Magnitude is like the length of that side. So really like this first part here, for A, I'm doing the magnitude squared. You remember from the previous slide, magnitude squared is just the dot product of itself. Yes. You good? Okay. Why are we what? Oh, what I just answered is what you're at. Okay, perfect. All right, guys, so let's actually try to use this formula. So you use this when you're looking for the angle in between two vectors. So I've given you two vectors here. So this one's negative 3, 1, and this one is 5, 2. So cosine of theta, we need the dot product of those two vectors. So that's negative 3 times 5 plus 1 times 2 over the magnitude of each. So what's the magnitude of u? Square root of 10, okay. And what's the magnitude of the other one?
I mean, 29.
29. 13, 29, they're close. Okay. You guys with me? Alright, so then cosine of theta equals, so my numerator, I've got what, negative 15 plus 2, so negative 13 over the square root of 290. Okay. What would you do now? No, not rationalize. Elizabeth? You don't have to rationalize. Inverse cosine. Yes, you would get out your calculator. What? Yes, inverse cosine. That's what rationalizing? No, that's not what rationalizing. Let's go ahead and be in degrees because your brain is more used to thinking in degrees. And let's just round to the nearest 10.
It's supposed to be.
No, inverse cosine should never give you a negative because it'll give you an answer between 0 and 180.
Oh, I don't remember that.
Nearest 10.
That's the top part, right? The top part of the circle?
Are we getting like 139.8? Okay.
Oh, man, I am broken this court.
I wanted like just like these couple long weekends.
Oh,
Ooh, actually your quarter test happens before the second long weekend, so.
okay. So wait, so between So like those 3 days that we have school. So
It
like
happens the
we do
18th and 19th.
review for one day. Like a review.
And guys, think about this. This should make sense to you. If I plot my two vectors, so u is -3, 1,
You're in radians.
and v is 5, 2. Guys, if you look at those two vectors, does that seem like that could be about 140 degrees in between them?
Yeah.
Yeah, so if you're ever not sure, like sketch the vectors and then look at the angle. Does it make sense? Does it not make sense? Okay? So it's good to have a way to think about them. Grace, I feel like you have a question.
So I was attempting to get help from my sister on this, and like it confused me because when I was doing homework, she wasn't doing this, but she was like, I guess it's separate my knowledge. She like drew a line, and then like drew a science stuff that like.
So I think you're thinking of a different part of the homework. I think you're thinking of find the magnitude and the angle of the vector, which is different than
That's not what we're doing.
that's not what we're doing. Okay. All right. Any questions on this, on finding the angle between two vectors? Okay. All right. Let's turn the page. We're going to do a plain word problem now. All right, guys, so we have a plane that is flying 500 miles an hour due south, and then the jet stream, which is the wind, is 80 miles an hour in a northeasterly direction. We have to find the actual speed and direction of the plane. So you guys understand that when the wind is blowing on the plane, it's not still going to go straight south? Does that make sense to everyone? Okay, so let's make a picture here. Sure, right? Like it's blowing you off course.
Yes. I don't know how to convect it.
Well, we'll look at it. Okay, so we're going to start from the origin. So 500 miles, I'm just going to take up 5 spaces. So that is like what the plane is doing to begin with, right? That's the vector for my plane. It's flying due south, 500 miles an hour. So let's write component form for that vector. What would you tell me? Think about the ordered pair. Where does the vector end up? Like that?
Got it.
Hold on. When we need a three-dimensional plane, because the plane,
No. We don't.
are we just assuming that the plane's at a constant height?
I think we're only looking
You're not worried about the height of the plane right now. It is cruising. It's settled into the altitude it is flying at, and it is steaming. All right. Does everybody understand vector for the plane?
Yes.
You have a question?
What's velocity? That was the question. I didn't hear you.
Speed with direction.
I don't think this is something I would grasp right now.
Speed and direction, like vectors that we've been doing the whole time, magnitude and direction. All right, guys, let's look at the wind. 80 miles an hour northeast. If it's exactly northeast, what do you think that means for angles? 45 degrees. Yeah, so I'm going to draw like a little vector here. I don't know exactly where my 80 is going to be, but I'm just estimating here. So I'm going to call that VW for like the vector of the wind. I said I'm guessing it's an 80. I don't, that's just drawing a little vector. It does not have to be perfect with your graph, okay? Now guys, that is coming from the origin, so that's like my position vector. But I would like to use the head to tail method here so that I can see like, oh, it's pushing the plane that way. So I'm going to go ahead and bring it down here and draw it again. Okay. we got to figure out the vector, the component form for our wind. So, do we know the magnitude of it? 80. And we know the angle, right? Do you remember this?
Yeah.
We'll turn it back into component form here in just a sec. So 80, and then you've got your cosine and sine of 45 degrees. Yeah. You got it? Okay. No? What position? So on day 1, we talked about how you could write it in terms of the angle and the magnitude, and that's what this is. And it should make sense that the cosine is the x piece and the sine is the y piece. Yeah, like magnitude, yeah. I thought you said that's the blank. I was like, I don't know what that means. All right, what is the cosine and sine of 45 degrees? Okay, and what is 80 times root 2 over 2? Which reduces to 40 root 2. So that is the vector for your wind. It's 40 root 2, 40 root 2. So hold on one sec, sorry. So something to think about, like, if the wind had been blowing in the opposite direction, what would change here? Like, do you understand that you'd have different signs? Okay, yeah, so think about what quadrant, like, where the original vector is. Sarah, what was your question for?
Why 45 degrees?
Because it says exactly northeast.
Oh.
It may tell you something else. It might say, like, north 30 degrees west or south 25 degrees east. And then you have a more specific value, but this, when it's exactly north and east, that's 45 degrees. Okay? All right, so far so good? Okay. I am now going to draw in the vector that represents where the plane actually is, okay? And I'm going to call that P actual. I just connected from the origin to where I'd done the head to tail method. Yeah, okay.
Wait, so the point where, so it's 40 square root of 2.
So we're going to get to the component form in just a second. Is that what you're talking about? Okay. So guys, we need the component form of that vector. I have done vector addition here, right? Haven't I just done the head to tail method to get that? So you just have to add these two vectors together. So what is 0 plus 40 root 2? 40 root 2, good work, guys. And then I have negative 500 plus 40 root 2. And you can just write negative 500 plus 40 root 2. Okay. You're still living. Once you have all of those vectors in component form, the rest is really not that bad. I need to know the speed and direction of where the plane actually is. So the speed, that's the magnitude of that actual vector, my green vector there. So I need magnitude of this guy. You would absolutely have a calculator for this. So square root 40 root 2 squared plus, and then this big quantity, negative 500 plus 40 root 2, all of that squared. Use your parentheses. And let's see what you get for the actual. And I don't remember what it is, so you guys have to tell me. Do you think it should be more or less than 500? Less. Okay, good. Let's go to 10. What are you guys getting? So So we'll go 447. So that means the speed of the plane. And Grace, I'll come look at yours in a second. It's 447 miles per hour. Okay. Way more than 500. All right, so we're okay with magnitude. We know how fast the plane is going. Does that make sense to everybody? Okay, direction. Do you guys see that I'm going to need, and I don't know that I can even squeeze it in here, that little theta, like the angle there? It just looks like a blob. Yeah. That's the angle between two vectors, right? Did we just learn a formula to find the angle between two vectors? Yes. Okay, which two vectors do I need? Wind, plane, or actual? Which two? Plane and actual. Okay, so those are the only two you're going to do to find the angle. So we will start. So cosine of theta. Now this is the dot product between the plane and the actual. So that's 0 times your 40 root 2. So what's that going to be? 0 plus then negative 500 times negative 500 plus 40 root 2. Okay. And then do we already have the magnitude for each of those? Because what was the speed of the plane? Like, what's that like? 500. And then what did you just find for the plane?
447.
Yeah. Could you have stored that 447 and used that stored answer?
Yeah, and you really should.
You really should.
Is what you'll probably say, right?
Yep. Okay, and so then what do you use on your calculator to find the actual angle? Inverse cosine, okay. And let's just round it to, I don't know, let's just go nearest degree. Your face does not look happy right now. So the formula we just had on the, I think it was the last slide, cosine theta equals u dot v over magnitude of u times magnitude of v. So I did the dot product between the plane and the actual. So 0 times 40 root 2 is 0 plus negative 500 times that. That's my numerator. And then the two magnitudes, the magnitude of the plane, that's 500. And the magnitude of where the plane actually is 447. So those are my two denominators. Okay. What are you guys getting for an angle? 7. Yes, I like 7.
I got error syntax.
Okay, try again. Now your answer is not just 7, but I want to wait and make sure everybody gets here. No. Second, did you get it?
It's supposedly the fact that I got So
start over. I would do the fraction key shortcut. All right, guys. So the way you describe this, 7 degrees doesn't really tell me a direction, okay? So the way you start, you always say north or south first. So where are we? South, and then it's 7 degrees east or west. What do you think? Okay. So your answer is south, 7 degrees east. So these are the two pieces. Okay. All right. I know your calculator's clearly not your friend there today, but other than that, are we okay?
Yeah.
Get what's happening? We still have just 2 little pieces left, but are we okay so far? That's clearly like the biggest chunk, the biggest problem there, trickiest part of this. I believe your quest is all non-calculator. Mr. Matthews, can you confirm? Yeah. So the word problems will be like setting up. You won't actually have to get to this final like decimal type thing. You may have to do angles that you know from your circle, but it won't be anything other than that. So you won't have to do like the inverse cosine piece because you won't have a calculator. All right. So let's see. Today's Tuesday, right? I'm looking at the calendar. Just looking at the space. So tomorrow review day. Yours is Thursday.
Oh no, I've got it. As it turns out, I was using the the whole thing rather than.
So you only want one 45-minute period of review for your quarter testing?
What?
I was gonna say maybe we
I want it on the Friday.
I need quarter
Your quarter test is next week, Wednesday, Thursday, no matter what though. So yeah, maybe not. All right, guys. So all we have left are parallel and orthogonal vectors. So I don't know why we had to come up with a new word for perpendicular, but that's what orthogonal is talking about. First, for parallel vectors, what do you know about parallel lines?
That they will go on for, if they were extrapolated to go on for eternity, they would never touch.
Okay, what do we know about the slope? Okay, same slope. So let's look at our 2 vectors here in the example. Vector B, do you guys agree that the slope of that is -3/2? Right, changing y over changing x? Okay, I'm getting a face back there. So if I plotted 2, -3, isn't the slope down 3/2? Yeah, okay, that's a better face, all right. And then if I look at vector W, what's the slope of that? -6/4, which is -3/2. So those are parallel, okay? And that's really all you have to do to check to see if they're parallel or not. So let's look at these 2 here, vector V and vector U. What's the slope of V? How about -1/3? Okay. What about U? That is not -1/3, correct. That's 12/8. So, no, those are not parallel. Questions on that? Yeah. Yeah, if they have the same slope. Yep. They're not equivalent vectors, but they can be parallel. Yeah, so you can be parallel without being equivalent. All right. So let's look at orthogonal. There's 2 ways to do orthogonal. First one, we're going to think about if lines are perpendicular. What's the angle between them? 90 degrees. Okay. So what is the cosine of 90 degrees? 0. So do you remember that's our formula for the angle between 2 vectors, u dot v over magnitude u magnitude v? So if the angle between them is 90, that all has to equal 0, okay? And if you want your fraction to equal 0, just the numerator has to equal 0. Okay? So we can look at this and do these this way. So let's find the dot product of u and v here. So I would do 2 times 9 and -6 times 3. What do I get? 0, okay. So are they orthogonal? Can anybody think of another way we could look to see if they're orthogonal? Slopes, what do we know about perpendicular slopes?
They are,
Opposite reciprocals, yes. So, let's look at my two slopes. For V, what's the slope? Yeah, -6/2, which is -3. And what about the slope for vector U? What do we get? 3/9, which is 1/3. So -3, 1/3. Does that work? Okay. I think that's the simplest way to look at it, but whatever way makes sense to you. All right, guys. That's the end of your notes for vectors. Questions? It's a quick unit. Very, very fast unit.
so extensively, this is the opposite where slopes of slopes, but the W, big slope.
Okay. Slope V, slope, okay.
I was just
Yeah. Okay. But yeah, they just have to be opposite reciprocals. Okay. All right, guys. In your packet, you already started on it yesterday. Homework 4.5, day 2. You also might want to start taking a look at your review. We will have class time tomorrow just to review, so you can work on the review then if you would like. But then your quest is on Thursday. Okay? What? It's in your packet. I said they could start on it last night because they knew how to do the first page, but none of it was due today. Okay?